What do you think of when you hear STEM? What type of person comes to mind? Are they male or female? Are they white, black, Asian, or another race? To many people, the image that comes to mind is a white male. It is well known that women and other minorities are not well represented in STEM. Why is this? As teachers and school administrators, you have the opportunity to change the way STEM is viewed and ensure that more women and people of other minorities go into STEM. In this talk, we will be discussing some of the issues related to why women and other minorities are underrepresented in STEM and discuss some programs that are currently in place that help promote women and minorities in STEM. We hope you take this information and use it to change the way you promote STEM in your own classroom. We all know high school is a critical time in the lives of young adults. They have to deal with growing up and trying to figure out who they want to be. It is also a critical time for the STEM field, as this is when men and women often choose whether or not they are interested in a STEM career. A study by Sadler et al. Looked at how both male and female's choice of going into STEM changes over their high school career. It was found that the male's interest changed from 39.5% to 39.7%, while for females it changed from 15.7% to 12.7%. It also found that the overall number of students interested in STEM at the end of their high school career was only 25% women, and that males are 2.9 times as likely to choose STEM over women. These statistics show that starting in high school, women are already less likely to go into STEM, and this has a big impact on the STEM field. Less women means less variety in the work field. This can lead to less innovation because there are less viewpoints and differing opinions. As teachers and administrators, these numbers should shock you and make you want to make a change. As educators, it is your job to teach and encourage all of your students to work hard and be successful. Looking at these numbers, it is clear that the promotion of women in STEM needs to start at the high school level or earlier, and you have a big role in improving these numbers.
In 2012, the President's Council of Advisors on Science and Technology reported that at current rates of training and education, we would be at a 1 million worker deficit to meet the United States workforce demand in the next decade. Since women are so underrepresented in science, technology, engineering, and mathematics majors, this data sparked a large push in recruiting and also retaining women in the science fields in order to address this deficit. The push raised the question of why there are so few women in the STEM fields in the first place. In an attempt to answer this question, a study was conducted to identify if discrimination in science exists in the modern-day world. Both male and female faculty were asked to evaluate an applicant for a laboratory management position. The applicant for this position had the same exact resume, but to some of the subjects, the applicant was female, and to some, the applicant was male. In all cases, the male applicant was deemed significantly more hireable by both men and women faculty. Also, the male applicant was offered a higher starting salary than the women applicant by approximately $4,000 per year. This article demonstrates that even though it may be subconscious, professionals in the education system do have a bias against women. This may very well be an underlying cause in the small amounts of women that participate in this discipline.
It is important to not only understand why students might lose interest in STEM, but how your own personal biases can discourage your students from pursuing STEM fields. A study by Joachim Tiedemann describes an experiment conducted to analyze the biasing effect of gender stereotypes, specifically the assumption that boys have a higher ability, confidence level, and effort in mathematics, on teacher impressions of their 3rd and 4th grade students' competence and effort in class. Results showed that teachers who endorsed this gender stereotype tended to attribute higher ability and effort to their male students than their female students. Instructor perceptions of ability and effort indicated a clear bias that favors males and could be detrimental to female achievement. We would not only like you to be aware of this biasing effect of your opinions about gender, but encourage you to take steps in ameliorating issues that result from introducing your personal biases into the classroom. We recommend instituting an assessment of teacher stereotype predisposition upon hiring, so that they may be assessed in their ability to teach as well as their ability to create an all-inclusive environment. Stereotype threat is a significant factor in a young person's performance, especially for young girls going up against the stereotype that boys are better in math. Just thinking about it can cause girls to perform below their skill level on a math test. Shapiro and Williams found 4 ways to counteract stereotype threat that can easily be implemented in a classroom. The first type of intervention is self-affirmation. This method involves reflecting on an important aspect of one's life that is outside the realm of the threatening domain. Before a test, teachers can simply ask students to reflect on something they are good at. The second method is presentation of role models. When a girl sees someone who disconfirms a stereotype, she no longer feels the burden of disproving that stereotype. Another method is reducing intergroup boundaries. When girls are asked to consider characteristics that men and women both have, they perform better against the negative stereotype that boys are better at math. Finally, the article advocates for teaching about the phenomenon of stereotype threat, simply explaining how stereotype threat works to students may help reduce its negative effects.
We would also like to point out the potential discrimination that occurs in a common environment, the science laboratory. The lab is the first place young students start to develop an identity in the scientific community and gain exposure to the realm of applied science and math. Malone and Barbino discuss these concepts of identity and interview college students to investigate how prejudices can impact the success of minority students in science. Three main themes of identity were discussed: isolation, marginalization, and invisibility. It is important to recognize that these themes are not confined to university-level students, but can be seen in middle and high school environments. A scientific identity is produced through the interactions where one is seen and heard as well as seeing and listening, and starts to develop early on in a student's academic pursuits. It is your job to recognize and respond to students' complaints of marginalization, invisibility, being out of the loop, racialization, and feeling undervalued. We recommend sensitizing students to these issues through discussion so that students will take responsibility of their own success in the lab.
The United States is significantly behind in STEM education and careers in the field when compared to other leading countries in the developed world. There are ways we can engage students and help them grasp concepts more effectively. We learn these theories from studying countries who have succeeded in education and retention in STEM majors. One theory is vital to success with this subject. Since science and math courses use a hierarchical learning system, we must create a uniform curriculum. Students need to be able to advance to higher levels of courses with the same information so that they are not left behind over time. Educators can also focus on creative interactive situations in which students are required to solve problems. Since science and math are very tangible concepts, this could be, and has proven to be, a notably effective approach to learning. This will give the students insight of what it means to be a scientist, engineer, or mathematician. There are countless solutions to get students interested and engaged in STEM fields. To succeed in retaining students in the sciences will be to make learning an interactive, social environment full of observation and expressing research and results. That will be the key to engaging students.
One program that is currently being used that has had success is the WISE program. WISE is a program that includes first and second year women who are majoring in the various STEM fields. The program provides its members with a support group of friends and mentors that are also studying STEM. It also provides opportunities where they can talk with professional women who work in STEM, and they can learn about their successes and get advice. One study by Rosenthal et al. Looked at the impact WISE had on women in STEM from the beginning of their first year to the beginning of their second year in college. On a scale of 1 to 7, it was found that the participants in WISE had a 5.91 score of social support and 5.35 for support from WISE, and on a scale of 1 to 10, a score of 6.74 for a sense of belonging in STEM. These numbers show that WISE is making a positive impact on these women and will continue to improve as the program develops. By promoting WISE and other similar programs in your schools, you can show these girls that there are support groups and others who have been successful in STEM. This could give them the confidence they need to pursue and be successful in STEM.
There are several factors at the university level that affect whether women and minorities who initially chose a STEM major will stay in that major until they graduate. A study by Amanda Griffith found that there are three main factors that influence this: the relative amount of undergraduate and graduate students, research expenditure relative to educational expenditures, and faculty role models. Universities that have a higher ratio of undergraduate students to graduate students are more likely to retain women and minorities in STEM. Further, schools that spend more money on undergraduate education than on research will also retain more students. Lastly, there is a correlation between women in STEM and women faculty role models. There are clear implications from these factors for school administrators. An effort should be made to hire more women faculty and to invest more time and money into the undergraduate programs if a school wants to keep more underrepresented students in STEM.
The low number of STEM degrees coming from women and minorities is caused by a variety of different factors. As a school administrator, you are in a unique position to help level the playing field for your students through the use of school programs. In an article by Anya et al., the authors give several strategies for success in increasing participation in STEM fields. The first is peer-to-peer knowledge transfer, where one student is teaching course material to another student. It has been shown that most underrepresented groups cite an unwelcoming atmosphere from faculty in STEM courses. As a result, they do not get a STEM degree. The peer-to-peer strategy is a way around this challenge, and it also creates a positive mentoring relationship between students. Another important strategy to cultivate diversity in STEM is by using bridge programs. Bridge programs are when universities and high schools work together to help students earn STEM degrees. By working in cooperation with a university that has a strong STEM program, your women and minority students will have a better chance at success. One final strategy that you should try is to promote STEM-themed summer camps and classes. In the same article, Anya et al. Conducted a study of Southwestern University's summer program, a program designed to give high school students exposure to a variety of STEM fields. After taking surveys before and after the program, they found that the program had improved the students' knowledge of STEM topics, and every student expressed an increased interest in STEM fields. Summer programs like this could help give students an extra push they need to pursue a STEM degree.
STEM is a field that is very relevant in today's society. There are many opportunities for those who pursue STEM, but unfortunately the number of women and minorities in STEM is small. This needs to change, and it is your job as teachers and administrators to help make this change happen. Through this talk, we hope you have been provided with enough information on reasons for these low numbers and programs that are being used to change these numbers. It is now your job to take this information and make a change in your schools. We thank you for your time and attention and wish you luck as you implement change.